Welcome to this lecture on process control, chapter 2, Laplace transform, part 17. In the last four lectures, in the last four videos, we have been finding the inverse Laplace transform of certain useful functions. And in this class, we will find for one more function. The function is one by s square into tau s plus 1 whole square. So this can be, as usual, we'll be doing it by splitting into partial fractions. So there will be four terms because there are four factors in the denominator. S square, s repeated twice, and tau s plus 1 repeated factor twice. So there will be four terms. So let us split this into partial fractions, a, b, c, d, involving a, b, c, d, and evaluate these constants. So if you split this is a by s. A by s, b by s square, because s is repeated. So you would have 1 by s, a by s, and b by s square. Similarly, tau s plus 1 is repeated, tau s plus 1 and d by tau s plus 1 whole square. So if you multiply throughout by the LCM, as into tau s plus 1 whole square, you can b into tau s plus 1 whole square, c into s square into tau s plus 1 plus ds square equal to 0. Equal to 1, sorry, equal to 1 this side. Equal to 1, equal to 1. Now let us evaluate this constant a, b, c, d. So simple one, first put s equal to 0, that is very simple. With s equal to 0, this term becomes 0, and here s is 0, so b tau, but s is 0, so b into 1 will be 1. This term will be 0, and this also will be 0, and right hand side is 1. So we get b equal to 1, b equal to 1. Next, let us substitute s equal to minus 1 by tau. So when you substitute s equal to minus 1 by tau, that means tau s plus 1 becomes 0. So this term becomes 0, and this also 0, this also 0. So you have only the last term. With s equal to minus 1 by tau, you get d into 1 by tau square equal to 1. So we get d equal to tau square. So next, let us compare s cube coefficients. So s cube is there in the first term here. Here s cube term will be a tau, or this is tau square s square. If you expand this, tau square s square into s, it becomes tau square s cube. So into a. So s cube term is here is a into tau square. The s cube term here, the first term is a into tau square. And then s cube term is here. This will be tau square s cube. No, it's not here. There's no s cube in the second term. The third term you have c s square into tau s cube. So it will be c tau. So a tau square plus c tau equal to 0. There is no s cube term in this right hand side, so it will be 0. So a tau square plus c tau equal to 0, or a tau plus c equal to 0. So this is one equation. So still you have to evaluate a and c. So next let us compare s coefficients. So let us compare s coefficient. So where is s? In the first term here, you will have A into S. So you have A. Then in the second term, do we have S? Yes, 2 tau into B. Here you have 2 tau into B here. Second term here. So 2 tau B. And any other S term? No, here S square, here S square. So no other S term. So right hand side S term is 0. So you get A plus 2B tau equal to 0. And already you have found BS1. So since you have found BS1, we have found BS1. So if you substitute here, A will be equal to minus 2 tau. So we got A, we evaluated A, B and D. Then let us substitute this A in the previous equation here. So we have A tau plus C equal to 0. We substitute A here, minus 2 tau square plus C equal to 0, or C means C equal to plus 2 tau square. So we have found A, we have found C, and already we have found B and D. So let us substitute A, B, C, D into the given equation in this equation. So let me substitute A, B, C, D in this equation. So I have substituted the values of A, B, C and D in this equation. Substituted for A, B, C and D. This is B, this is D, and A is here, C is here. Okay. So when I substitute, I get this equation. So this is A by S, this is A by S, B by S square, and C by tau S plus 1, and D by tau S plus 1 whole square. Let me take in L inverse Laplace of the whole equation. So we're going to get Ft equal to, this is 1 by S form, first term. So it is simply minus 2 tau, and 1 by S square is T, and 2 tau square inverse of 1 by tau S plus 1. We have seen in earlier part, we have seen in part 13, inverse of 1 by tau S plus 1 is into e power minus t by tau. And the inverse of the last term, tau square divided by tau S plus 1 whole square. And inverse of this 1 by tau S plus 1 whole square, we found in the previous parts. You may refer to the previous lecture. Part 16, I think. 1 by tau S plus 1 whole square is t by tau square into e power minus t by tau. So I written the inverse Laplace of every term. First term is minus 2 by tau, minus 2 tau. Second term t. Third term 2 tau square into t by tau, e power minus t by tau. And the fourth term is tau square into t by tau square, e power minus t by tau. So There's the correction here. This is third term is here. This must be 1 by tau only. There's no t here. There's no t here. Okay, this is simply 1 by tau. Inverse of 1 by tau s plus 1 is 1 by tau into e power minus t by tau. So let me correct it. Yes. So third term inverse is 2 by tau s plus 1. Inverse is 1 by tau into e power minus t by tau. By mistake I written t here. This is only 1. Okay, this is 1 by tau. Simplifying this, we get, let me write this. Here 1 tau. So this term becomes 1 tau cancels. So you get 2 tau e power minus t by tau. You get tau square and tau square cancels, plus t into e power minus t by tau. This is the inverse Laplace of the given function. This one. So earlier in my last lecture, I had given this as an exercise, and those who have done this can verify your answer with this. So this is the answer, inverse Laplace of the required function. So in the last few lectures, 4 lectures I think, I had found the inverse Laplace transform of some 8 functions which are going to be very useful in the study of process dynamics. I hope you had followed all these functions and you have understood these. If you have any doubts, if you have any questions, you can leave it in the comment section below. Please subscribe to this channel so that you get notification of my upcoming lectures. So we'll come with more lectures on Laplace transform related to process control. See you till then.